Welcome to Sysketch, where we explain how programming systems work using clear visuals and no code. Every time you type a website address and press enter, something extraordinary happens in under 200 milliseconds. Your computer finds the right page from billions of possibilities scattered across the entire internet. It does this reliably almost instantly every single time. But how does it know where to look? How does it find one specific server out of hundreds of millions spread across the planet, faster than a human eye can blink? That invisible process is called DNS, the domain name system. It is one of the most critical and most overlooked pieces of technology running behind everything you do online. Most people have never heard of it, but without it, the modern internet simply would not function. Every website you visit, every email you send, every app on your phone, all of it depends on DNS working correctly, silently, in the background, billions of times every single day around the world. Here's the problem that DNS was invented to solve. Every device connected to the internet has a unique numerical address called an IP address. Google's actual address is 142.250.80.46. That is literally where their servers live on the internet right now. But nobody can remember a number like that. And those numbers change all the time as companies move their infrastructure to new data centers and new locations. So, in 1983, a computer scientist named Paul Mockapetris designed a system that automatically translates human-readable names like google.com into the machine-readable numbers that computers use to find each other. That system is DNS, and it has been quietly running the internet ever since. The easiest way to understand DNS is to think of a phone book. You know the name of the person you want to reach. You look up their name. The book gives you their telephone number. You dial. DNS works exactly the same way. You type google.com into your browser. DNS looks up that name in its distributed directory and returns 142.250.80.46. Your browser connects to that address. The page loads. Without DNS, you would need to memorize a completely different numerical address for every website you ever want to visit. There are currently over 350 million registered domain names on the internet. DNS makes every single one accessible by simply typing a name, instantly, every time. DNS is not one server sitting somewhere with all the answers. It is a chain of 5 servers, and each one knows a little more than the last. When you type google.com, your computer does not go directly to Google. It goes on a journey. Let us walk through each step. Step 1. Before your device makes any network request, it checks its own local DNS cache. A small database of addresses it has already looked up recently. If you visited Google an hour ago, the IP address is almost certainly still saved right there on your machine, and your browser can connect instantly without any network communication at all. This is why revisiting websites feels so fast. But DNS records have an expiry time. When the cache has no valid answer, your device moves to the next hop. Step 2. Your device contacts a DNS resolver, a server run by your internet provider whose entire job is answering address questions on behalf of everyone on its network. Think of it as a dedicated librarian. Your device asks, what is the IP address for google.com? The resolver checks its own cache first, because it handles thousands of identical queries from thousands of customers every single minute of every day. If it has a recent answer, it replies immediately and the lookup is complete. If not, it has to go hunting further up the chain. Step 3. The resolver contacts a root server. There are only 13 sets of root servers in the entire world, but they are replicated at over 1,000 physical locations for speed and resilience. Root servers do not store individual IP addresses. What they know is which servers are responsible for every domain extension that exists. When the resolver asks about google.com, the root server says, I do not have Google's address, but I know exactly who manages all .com domains. Go ask them. Step 4. The resolver contacts the TLD server. TLD stands for top-level domain, that is the .com part of any web address. This server manages every single .com domain that has ever been registered, but does not store Google's specific IP address. Instead, it knows that Google operates their own authoritative name server. It tells the resolver, go and ask Google directly. Step 5. The resolver reaches Google's authoritative name server, Google's own server holding the definitive official answer. It responds with 142.250.80.46. The resolver passes that back to your device. Your browser connects. The page loads. And your device saves the answer locally, so next time you visit, step 1 succeeds instantly. 5 hops. A complete round trip. In under 200 milliseconds. DNS is why the internet scales to hundreds of millions of domain names without anyone maintaining a central master list. When a company moves its servers to a new data center, they update one DNS record, and every device in the world finds the new address automatically the next time their cache expires. The migration is completely invisible to users. Every email you send begins with a DNS lookup to find the recipient's mail server. Every app on your phone uses DNS to locate its backend servers. Every video stream, every payment, every map. All of them start with DNS before anything else can happen. But DNS can also be a target for attackers. In a spoofing attack, a hacker poisons a resolver's cache with a false IP address. You type google.com, everything looks completely normal, but you land on a fake site and hand over your credentials without ever knowing anything went wrong. This is why DNSSEC was created, a layer of cryptographic signatures that lets resolvers verify that every answer in the chain is genuine and has not been tampered with. DNS converts names into numbers. It runs silently behind everything you do online, and now you know exactly how. Before we walk through each of those steps, it is worth pausing to appreciate the sheer scale of what DNS does every single day. According to Internet Infrastructure Research, there are somewhere in the region of 1 trillion DNS queries processed globally every single day. Every single time someone opens a browser tab, taps on a notification, refreshes their email, or starts a video, a DNS lookup happens first. It is the first thing the internet does before anything else can take place. And it does all of this with extraordinary speed because of a design decision that was baked in from the very beginning of its creation. No single server knows everything. Responsibility is distributed across a hierarchy of specialist servers, each handling just one small piece of the puzzle. No single point of failure. No single organization in control. Just an elegant chain, working together, serving the entire internet simultaneously. There's also something deeply clever about how DNS handles the problem of scale. Rather than having one enormous database that every device in the world queries directly, which would be impossible to maintain and would collapse under the load, DNS distributes the work. Your device handles what it already knows. Your provider handles the most frequently asked questions for its customers. The root servers handle only the broadest routing decisions. The TLD servers handle their specific domain namespace. That is DNS. Thanks for watching.